Problem says, how many pounds of peanuts that cost $3.60 a pound must be mixed with 40 pounds of cashews that cost $9 a pound if you want the final mixture to cost $6 per pound? So this is going to involve setting up a system of equations based on the previous examples that I had done with mixtures of this same type. This time we're being asked for a weight. So one thing that's always going to be true is that the total weight will be the sum of the weight of one of the components, let's call it C for cashews, and the weight of the other component, and we can call that P for peanuts. Now, right now, we don't know the total weight, and we don't know the weight of the peanuts. That's actually what we're being asked for. But we do know what the weight of the cashews is. So we definitely can't solve it from this alone because we would have two unknowns. We also have this formula that the total cost will be the cost of the cashews plus the cost of the peanuts. So I'm just starting from some simple equations that we had used in the past to describe this situation. Right now we have a lot of unknowns. The only thing we really know out of all these is we know the weight of the cashews, 40 pounds. We don't know any of this other stuff. So we want to try to do some substitutions if possible. Now, we said before that a rate in this situation would be calculated by the total cost divided by the weight. So if we rearrange it, we find that the cost is going to be the product of a rate times a weight. And that means that we can actually substitute this in place of where we have a cost in our formula. Okay, so let's try that. That would give us the total rate times the total weight, and we'll have the rate of the cashews times the weight of the cashews, and we'll have the rate of the peanuts times the weight of the peanuts. The reason why this helps us so much more is we actually do know all the three different rates. This is the rate of the peanuts, and this is the rate of the cashews, and our rate total is right here. So we can plug a lot of this in for the rate total. Let's just put in that $6 per pound. And we don't know what the weight total is yet. For our rate of the cashews, we can put in $9 per pound. And we know the weight of the cashews is 40 pounds. Our rate of peanuts is $3.60 per pound, and we just don't know the weight. So one option is to make it a variable like x. We'll let x stand for the weight of the peanuts. Okay, so here we would have that the total weight is equal to 40 pounds plus some unknown value, which we're trying to find. But since this represents our total weight, we can actually plug that in to our expression right here. And so we'll get 40 pounds plus X. Now it's an equation that we can solve for X. At this point, I can remove the units, but we'll assume that the units are there. It just makes the algebra a little bit easier to do. So we'll have 240 plus 6x, if we just distribute that 6, equals 360 plus 3.6x. And we're just wanting to solve for x. So let's subtract the 3.6x, and we'll get 240 plus 2.4x equals 360. And we're getting toward an answer here. X is 50 pounds. So that's going to be the weight of the peanuts. Now we can verify that by plugging in. So 50 pounds of peanuts at 360 per pound must be mixed with 40 pounds of cashews at $9 per pound to create a mixture that costs $6 per pound. Now we can even check it. How could we check it? Well, take your 50 pounds of peanuts, multiply it by 360 per pound, and then take your 40 pounds of cashews and multiply that by its price of $9 per pound. This will tell us how much it costs in all to make this 90-pound mixture. Looks like it costs $540. But the total weight is clearly here going to be 50 pounds plus 40 pounds, which is 90 pounds. Now we can take those results and divide them to see what the rate really is. And if we did it right, it'll come out to what they said, which was $6 per pound. So divide the $540 by 90 pounds. It's $6 per pound. So it checks.